Hi, my name is Norman and I have been working on a secret little side project for a while now. Here, this is a mechanical keyboard. I designed and manufactured the entire case by myself. Every single switch inside here is hand wired. You're gonna get a separate video for that. It's probably also gonna end up being very long. Anyway, the one thing which is missing is actually the back plate, as you can tell. I actually didn't really film manufacturing the front plate where all the switches sit in. I didn't film it because, you know, CNC routing is completely new to me and I needed time and focus to get my head around it. Yeah, you can't do that when you're supposed to film, right? So now I know a thing or two about CNC routing and I can show you the nooks and crannies of that CNC router, because that thing is not easy. It's really weird actually. So first let me introduce you to that machine here. It's a SainSmart something 3018 Prover. As you can tell, I already modified it. I installed a drag chain because I didn't like how the cables were hanging around here. And also, maybe you can tell here from the base, it helps a lot with noise if you just, you know, add a little bit of foam. It helps a lot with the noise and vibrations. Also, here on the back side, I felt like the motor drivers were getting a little bit too hot. So I just cut a hole by hand into the back plate and installed a little fan. You can just turn it on by turning on the power, and then it's gonna cool the motor drivers. So now you're wondering, why did I install this sheet of multiplex? Because of tiling. Tiling means you are actually able to manufacture a piece which is larger than your build plate or whatever that surface here is called. It basically means you just put your sheet of material inside, and then you're only going to manufacture a selected portion of your entire piece. And then once you're done, you just move it a little bit and do the same. And you repeat it until you're done. And that's why I have this piece of multiplex inside, so that that sheet here has a little bit more support. Downside is, of course, it takes a little bit of your Z height. This machine, I think it has 40 millimeters. Give or take, and with this multiplex it takes 18 or 16 millimeters, I guess. Still plenty of room for a 3 millimeter acrylic sheet, but if you have something larger, maybe you're gonna have trouble. Anyway, we're gonna repeat the exact same steps, right? We're gonna tile the backside. We're just gonna generate paths for a portion of the piece, route it, move it, route it again until we're done. Okay, as you guys know, I am using Fusion 360 for all my CAD modeling, and as you also can tell, coloring the model black wasn't quite the wisest decision here, but for some reason I stick to it. So I am actually also using Fusion for cam. As far as I can tell, it's actually pretty good. Okay, we're gonna hide base plate and the middle because we're just gonna focus on the bottom piece. Especially we're gonna focus on this right section here because, as I mentioned before, we're gonna do tiling. Fusion has this really great feature where you can show green stuff, which is basically a stock. So I have the setup here. I set the stock to be the size of the model plus 10 millimeters of a border. That's just because anything beyond that isn't really much of my concern. With this green stuff enabled, I can tell how my tool is going to manipulate my stock. So the first operation is drill. So it's just a drilling operation here. Very conveniently, my tool is 3.175 millimeters large, and my holes need to be 3 millimeter. And you know, 3.175 gives me a little bit of wiggle room, so I can use my milling bit for drilling, which is very convenient, so I don't need to swap tools in between. Then the next operation is boring, and I'm not talking about the opposite of exciting, but you know, to bore holes. I'm just gonna make these holes larger, but not to the bottom, as you can see, but only 2 millimeters deep, so it's more or less going to countersink my screws so that they don't stick out too far of the bottom here. And the last step is going to be contour. It's going to go around my section, and also it's going to leave a bunch of tabs. That's just because yeah, I don't want anything to fly around. So yeah, you can break these out later easily by hand and then just file them off. As you can tell, I'm using multiple passes for the contour, but also for the bore, and that's just because I'm still slightly terrified of the machine here, and I really don't want 10,000 RPM to go out of control. So I'm using low feed rates and small passes, multiple passes. Yeah, because I'm not paying anyone and I'm not getting paid to do this, time is not that much of a factor for me. I rather have the safety. So looking at the simulation here, I think it's gonna work, and I think we can export it, right? And to export, we just right click and click new CNC program. In that case, folder is here, it's empty at the moment, and we're gonna name it bottom A because it's the bottom side and has, you know, it's the tile A. And then we're gonna click post. But before we load this to the machine, there's one thing we gotta do, which is we're gonna open it, and then we're gonna press Command plus until it's large enough for you to read, and then we're gonna look at the code. And here you can see the first thing it does, it goes to X0 and Y 78.2, and then it goes in the Z axis up, and that's a problem. The home, the starting point of the machine, is exactly where I set it. I set it to be here, above that corner hole, okay? So first thing it's going to do is going from that corner hole, first to the left, then it's gonna go up. And that way you will damage your stock. I already did that. So the one and only way around this is actually that you manipulate the G-code by hand. You tell the machine to go up before it does anything else. So this one here means set your spindle speed at 10,000 RPM, and before it does that, we want the machine to go up. So G0 means move command, basically, without feed rate. We're gonna press Z6. I don't know what T2 means, but basically it does T2, then it means move 6 millimeters up, then turn on the spindle, then do something else, and then move to the left, okay? So it means first go up and then to the left, and not first turn on your tool, then go to the left and plow through your stock and then do your thing. That makes no sense. So yeah, first go up, then turn on the tool, and so on. Okay, to start, we're gonna use that tiny controller here, and we're gonna plug in the SD card. The SD card goes in, boop. And now we're gonna start the homing process. So we're just gonna here enter, and then we're gonna click home. So now the machine is at its absolute 0 point. And now we're gonna use this Game Boy-like controller here to actually move the machine. You can see here is the steps in millimeter. This is 1. Gonna take 10 millimeters. Let's just move a little bit from the edge so that, you know, as you remembered, I set the 0 point on the hole. So it's gonna move a little bit to the left as well. Here's enough. And now to Z. Also from the Y, we're just going to move a little bit away from the edge here. So now comes the funny part. Usually if you press here, enter, and then 0, X, Y, Z, as you can tell, I moved the tool here. And that of course also moved it in the software, so we're not at 0, 0 at the moment, we are somewhere else. If I would press here 0, X, Y, Z, in my mind at least, it should 0 again, right? But for some reason that doesn't work. The only way to 0 the machine properly is to just turn it off and turn it back on again. Now it's at 0, and then we can enter and start the tool. Yeah, I'm just gonna let it run for a while without anything on the build plate, because that way I can find out if it would actually plow right through my stock or if it would work. I think it should work. Now we have the choice between two messed up stock pieces, because that's the only pieces I have left. Number one, this is one with two messed up holes. And number two, this is something, I mentioned it earlier, had it zeroed here and then it just went straight through your stock to the first hole, and then it started Z-lifting. I think I'm going to go with the holes here because I can just close them up with hot glue or whatnot. So we're gonna have holes in the middle. Maybe, okay, I can just have one hole here. I can move the part. Okay, first up we're gonna Game Boy our tool head back to position. So 40 millimeters in X, 20 millimeters in Y, looks about right. And you may be wondering, how do I fix that thing on the thing, right? I'm using double-sided tape. Sounds scary, but it holds up surprisingly well. Yeah, this entire thing here is with double-sided tape on the build plate, and now I'm gonna put that also with double-sided tape on my spoil board. Now, last thing to do is lower the tool until it touches the stock. Whew, okay, fingers crossed. Reboot. And then we can start the program. Let's go. Did you just... no! Did you just see that? Okay. Power off. This... unbelievable. Why did it return to home? That was the most retarded thing ever. Everything went perfect. And then it decided to go back home once it was done. See, now we have that line from where it finished and where it went back home. Oh, what a bummer, it went so well. I'm just gonna leave it that way. So for the next tile, we can just duplicate the first one because, well, that sort of worked, right? And we're gonna rename it first to bottom B, and then we gonna just change the parameters. So first thing to do is change the origin to that point, because that's gonna be our new origin. And then wait, okay, now it's already complaining. And well, we can just go through the operations here, right? So first 4 hole points, we're gonna just remove them and take 3 holes because reasons. In theory, the first hole is already drilled, but I just prefer to, you know, drill it again so that I know somehow that I'm at the right position. So already, yeah, 3 holes here, and the next is bore. For the bore, we just need to bore the 2 additional holes here because I don't need to do that again. And for the last part, we're gonna do the contour, and that's a little bit more tricky, but it's gonna work. It's more or less smart, but most of the times it's wrong. So yeah, you decide if it's very smart or not. But you can tell here the arrow is on that side of the contour. That means the tool would ride on the inside of our desired space. So that's completely wrong, obviously, You're just gonna click on the arrow and flip it upside down. That way you can tell the tabs are now on the outside and the arrow is on the outside, so that's where it's supposed to be. Same on the bottom here, click on the arrow, tabs on the outside. That's great. Okay. That one looks great. So we're gonna do the same. We're gonna create NC program and rename it bottom B. Save, save, open, Command plus. We're gonna do the G-code thing. And now what we learned, we also have to repeat this on the end. So I don't know exactly which one of those is the homing thing, but yeah, I'd prefer to have the tool as far away from my stock as possible, so yeah. So I think I got everything aligned, but but maybe for next time when I know that it's gonna be hard to align, I should, you know, drill some more alignment holes so that yeah, it's gonna be a little bit easier later. I'm just gonna let it run because this part is messed up anyway, and let's just hope that it's gonna be usable in the end. Okay, let's have a look, shall we? We had a tiny little happy accident here. It's design, it's art, okay, you wouldn't get it. Please just ignore this one here. Yeah, in case you planned on copying my genius G-code manipulation idea, don't. I mean, yeah, it works if done correctly, but I think I missed one or two G-code commands, that's why. It still wanted to home and drove right through my stock. Same here, same here, same here. So, yeah. For the second and the fourth tile, it somehow worked, but for some reason still ended up going through the stock. Yeah, I think next time we're gonna get it right. For this piece here, I think it's just gonna be fine because it's just gonna be the underside and protect the piece from dirt and whatnot. Still, we're not quite done yet. We got a bunch of things to do. We're gonna start with you know, cleaning up the edges here. They came out pretty rough, and yeah, we're gonna sand them down real quickly. Okay, that should do the trick. And next up are the holes. So you can see here, for example, that hole is not centered. This one is even worse. And well, all of those holes are basically off center, and I don't know why. So I can't tell you why these holes are off center, seriously. I have no idea why, but they are. But luckily that's also easily fixed. I have this set of key files, and we're gonna take the round one and file them into the center. It doesn't really need to be too perfect here. These holes don't really need to be aligned. Well, I mean, the screws fit in pretty nicely. Wow, that's neat. But we have much bigger problems, which is, well, my CNC machine is not really dialed in, you know? And I decided to go with it and not dial it in because you can see here we got a slight banana piece, and I was hoping that if the bottom side is also not dialed in, it's going to unbanana again. Look, these pieces are supposed to be flush to each other, and yeah, I was hoping if both are bad, it's going to you know, straighten up again. But the problem now is that basically these holes don't really align. You can tell here on the x-axis, in my case, it's really off, not just a little bit by a long shot actually. On the y-axis it works more or less, but on the x-axis it's horrible. We're gonna do the same as I did with the front side, which is forcing those parts in. I'm gonna take a bunch of M3 screws, and I think we're gonna stick with those. No, the shortest one. I'm gonna take the shortest one because I have the most of them. So the way we're gonna force in The way we're gonna force in this piece is we're just gonna put in one screw, screw it down a little bit, and then go diagonal and do the same. Probably not gonna work. Okay, I don't know exactly how I'm going to manage this. Again, on the y-axis it works. All of those screws go in, but here it's off by, yeah, this one is going to, maybe it's going to fit, but the rest is just off by a millimeter or even 2 millimeters. So unfortunately we need to correct on both sides, otherwise it's not going to happen here. We are going to file down the holes to the inside. Okay, just the way Palpatine somehow returned, I somehow managed to get these screws into the piece, even though it didn't fit. And the banana is unbananaed, which is great. And I'm happy to announce that this keyboard is done, hardware-wise. Believe it or not, I'm actually really happy how it turned out. I mean, yeah, there's this little thing here in the back and there, but still, it somehow tells a story. And this thing here is actually the very first thing out of all the tools I got earlier this year. But about the keyboard itself, basically I'm working on it. I'm still having a little bit of trouble with the software. Hardware-wise, I fixed all the glitches here now. Hardware, I think it's perfect. Now it all comes down to software, and yeah, you will be getting a video soon, which in terms of my upload habits could be tomorrow or in 7 months. I don't know. It will be done when it's done, right? But anyway, I hope you guys enjoyed watching this video and see you in the next one. Bye bye.